Break out the champagne and buckle your seatbelts because we have absolute breaking news from the coast of South Texas. Welcome to Starship Flight 12, the historic maiden voyage of the Block 3 architecture, powered entirely by the legendary stripped-down Raptor 3 engines, and lifting off from the brand new Orbital Launch Pad 2 at Starbase. At exactly 5:30 p.m. Central Time, the flight controllers cleared the pad, the water deluge system roared to life, creating a colossal wall of steam, and all 33 Raptor 3 engines ignited simultaneously. For the first time, we saw the pristine, plumbing-free look of the Raptor 3 in action. No fiery restarts, no messy external shielding, just a blinding blue and purple column of over 18 million pounds of pure, unadulterated thrust pushing this brand new steel beast into the sky. Let's break down exactly what happened second by second, because while the mainstream headlines are screaming about a fiery crash in the ocean, the engineering data tells a completely different story. The clock hit zero, and Booster 19 absolutely tore off of Pad 2. During the initial climb, the vehicle encountered the very first test of its engine-out capability. One of the outer Raptor 3 engines shut down unexpectedly during the primary ascent. In the past, losing an engine early could spell disaster, but thanks to the new raw power upgrades of the Block 3 design, the flight computer instantly throttled up the remaining 32 engines to compensate. The stack punched right through max Q, the point of maximum aerodynamic stress, without breaking a sweat. At T plus 2 minutes and 24 seconds, the vehicle performed its signature hot staging maneuver. Booster 19 throttled down and Ship 39 ignited 6 upper stage engines while still physically attached, blasting itself clear. This was a textbook perfection. This is where the drama started. After separation, Super Heavy executed its rapid flip maneuver and attempted to light its core engines for boost back burn to head toward the splashdown zone in the Gulf of Mexico. But something went wrong. The booster was unable to ignite the full complement of planned engines. The flight computer detected an anomaly in the propellant manifold pressure and cut the boost back burn short. As the booster plunged back toward the ocean, it tried to execute its final landing burn. Only one single Raptor engine successfully ignited. One single engine doesn't provide anywhere near the thrust-to-weight ratio needed to stop a multi-hundred-ton steel skyscraper. Booster 19 slammed into the Gulf of Mexico at an absolute mind-melting speed of 1,450 kilometers per hour. It was an instantaneous high-energy impact that vaporized the booster on contact. SpaceX engineers revealed that a hydraulic pin in the launch tower's quick disconnect arm had failed to retract cleanly at liftoff, subtly damaging the secondary helium pressurization line at the very bottom of the booster. That lack of clean helium pressure ultimately starved the Raptor engines during the restart sequence. While the booster was turning into a supersonic kinetic missile in the Gulf, Ship 39 was busy putting on an absolute clinic in space. During its burn to orbit, the ship lost one of its Raptor vacuum engines. But once again, the Block 3 architecture proved its resilience. The flight computer kept the remaining engines burning for an extra 62 seconds to fully compensate for the lost thrust, successfully placing the ship into its precise planned suborbital trajectory. And then came the big surprise. SpaceX deployed a brand new payload delivery mechanism, an upgraded PEZ dispenser. Ship 39 successfully deployed 20 mass simulators, but alongside them were 2 highly modified, camera-equipped Starlink inspection satellites. These little satellites flew along Starship on the same trajectory, broadcasting high-definition, unedited footage of the ship's heat shield and structure in real time back to Earth. After a successful in-space Raptor relight demonstration, Ship 39 re-entered the atmosphere over the Indian Ocean. This wasn't a gentle re-entry. Engineers intentionally commanded a brutal dynamic banking maneuver at hypersonic speeds, violently swinging the ship side to side to test the absolute structural limits of the new, relocated forward flaps. Even with extreme aerodynamic torture, the heat shield held, the flaps remained fully operational, and Ship 39 executed a flawless landing flip, ignited 2 Raptors, and made a soft splashdown in the water before tipping over. The scientists in the control room didn't look disappointed about the booster. They were ecstatic. They just proved that a heavily damaged Starship can dynamically reroute its operations in mid-flight and still complete its core mission objectives. If you've been following the Artemis program, you know the original plan. Artemis 2 flies humans around the moon, and Artemis 3 lands them on the surface using SpaceX Starship HLS. Well, wipe that slate clean. NASA has officially updated its mission architecture, and the first crewed lunar landing has been formally moved to Artemis 4. Why the sudden shift? It's all about eliminating development and production risk. NASA realized that trying to execute the first crewed lunar landing and debuting a brand new, complex mission architecture all in one go during Artemis 3 was taking on an unacceptable amount of risk. Under the newly updated strategy, Artemis 3, now slated for 2027, will keep the same SLS rocket and Orion spacecraft setup as the Artemis 2. Instead of landing on the frozen rocks of the lunar South Pole, Artemis 2 will be a high-stakes, low-Earth orbit masterclass. The mission will send 4 astronauts into orbit to rendezvous and dock directly with SpaceX Starship HLS and Blue Origin's Blue Moon lander. Astronauts will spend weeks inside these massive vehicles while docked in LEO, testing out advanced life support systems, long-range communications, in-space propellant transfer operations, and checking out the brand new Lunar Extravehicular Activity spacesuits. By pushing the actual landing to Artemis 4 in 2028, NASA achieves 2 massive goals. Standardized configurations. They keep the SLS and Orion stacks in their reliable Block 1 setup for multiple consecutive flights, preventing unexpected engineering bugs. The geopolitical race. With international competitors rapidly advancing their own lunar plans, NASA is treating this like a military campaign. Step-by-step, highly repeatable flights ensure America builds a permanent presence rather than a temporary flags and footprints stunt. To support this hyper-accelerated NASA schedule, SpaceX is moving away from the older Starship prototypes we saw over the last few years. The future belongs to a new class of spaceships, Starship V3 and the mythical Starship V4. Let's do a deep dive comparison into these vehicles because the scale we're talking about here is completely unprecedented in human history. Starship version 3 that just flew on Flight 12 is an absolute masterclass in aerodynamics and structural design. First, let's talk about the flaps. On older versions, the forward flaps were positioned right where the plasma heat would wrap around the vehicle during atmospheric re-entry. This required heavy, complex seals and thermal protection material that was prone to breaking. On version 3, SpaceX shifted the flaps further back toward the leeward side. This completely shields the critical hinges from the direct blast of re-entry plasma, making the ship exponentially safer and easier to reuse. Second, a look at the length. Starship has been stretched significantly, allowing it to hold an extra 1,300 tons of cryogenic liquid methane and oxygen. This means it can carry double the payload to orbit compared to version 2. Elon Musk recently posted on X, "I'm highly confident that the version 3 design will achieve full reusability while carrying over 200 tons of payload to low Earth orbit every single flight." But SpaceX isn't stopping at version 3. Production lines are already preparing for Starship V4, scheduled to take flight as early as 2027. This vehicle is going to be a mind-boggling 170 meters tall. That's nearly 560 feet of stainless steel. To lift this monstrosity, the version 4 Heavy booster will expand its aft engine bay to hold between 36 and 39 Raptor 3 engines. The upper stage Starship itself will feature a jaw-dropping 12 engines, 3 standard sea-level Raptors for landing, and a massive ring of 9 Raptor vacuum engines with gigantic nozzles optimized for the airless void of space. This vehicle is specifically designed to minimize the number of tanker flights required to refuel the Artemis lunar landers in orbit. You cannot understand the jump to version 3 and version 4 without looking closely at the heart of the beast, the Raptor 3 engine. If you look at a photo of the older Raptor 1 or Raptor 2 engines, they look like a mad scientist's dream, a chaotic rat's nest of tubes, wires, and sensors, and secondary bypass valves wrapped around a metal combustion chamber. If a single piece of debris hit one of those tiny external lines, the entire engine could explode. Now look at Raptor 3. It looks completely naked. SpaceX managed to embed almost all the critical fuel routing lines, sensors, and secondary channels directly inside the internal walls of the engine component structures using advanced 3D metal printing and complex internal castings. By burying the plumbing inside the engine structure, SpaceX achieved 3 massive breakthroughs. Eliminated external shielding. Because there are no delicate wires or tubes exposed to the outside, the engines no longer need heavy, complicated thermal shields to protect them from the scorching heat of neighboring engines. Massive weight reduction. Raptor 3 is significantly lighter than Raptor 2, directly translating to more payload capability for the rocket. Increased thrust. Despite being cleaner and lighter, Raptor 3 generates a mind-blowing 280 tons of thrust, up from the Raptor 2's 230 tons. It operates at an internal chamber pressure that would instantly vaporize standard aerospace metals. To launch these massive Block 3 and Block 4 rockets, SpaceX realized that its single orbital launch pad at Starbase, Texas is a massive single point of failure. If an engine exploded on the pad, it could take 6 months to rebuild, grinding the entire American space program to a screaming halt. Orbital Launch Pad 1 is the historic pad that hosted all the early Starship launches. It is the pad that survived the legendary rock tornado of Flight 1 and saw the first successful booster catch on Flight 5. Moving forward, Pad 1 is being optimized as SpaceX's primary research and development pad. It will handle the experimental flight, structural stress tests, and early suborbital profiles for modified vehicle. Orbital Launch Pad 2, which saw its very first operational use during Flight 12, is a completely different beast. Built using lessons learned from years of pad damage, Pad 2 features a massive reinforced water deluge steel plate that can handle higher acoustic energy and thermal lids without degrading. Pad 2 is designed for rapid turnarounds. This dual pad setup ensures that even if one pad suffers a catastrophic launch anomaly, the other can keep launching the dozens of tanker flights needed to sustain deep space operations. While Starbase is the heart of testing, NASA's historic Launch Complex 39A at the Kennedy Space Center in Florida is being rapidly transformed into the operational headquarters for crewed Artemis launches. SpaceX has been leasing LC-39A for years to launch Falcon 9 and Falcon Heavy rockets, but the site is currently undergoing its largest expansion since the Apollo era. A colossal 347-foot tall Starship launch tower has been erected right next to the existing Falcon infrastructure. But launching a rocket as massive as Starship from Florida presents unique challenges that SpaceX didn't have to face in the remote deserts of Texas. The environmental protection barrier. Florida's Merritt Island is a protected wildlife refuge. The acoustic energy of a Starship launch can damage local ecosystems and structural foundations miles away. To solve this, SpaceX is installing a colossal industrial water suppression system that dumps hundreds of thousands of gallons of water per minute directly into a specialized refractory brick flame trench. The Falcon 9 coexistence dilemma. SpaceX cannot afford to damage the Falcon 9 launch mount at 39A because that mount is currently the only way American astronauts can get to the International Space Station aboard the Crew Dragon capsule. The Starship pad infrastructure has been engineered with blast deflector walls made of thick armor plating to ensure that even a catastrophic explosion on the Starship mount will leave the Falcon 9 launch hardware completely unscathed. Because Starship is so large, it burns through almost all of its fuel just reaching low Earth orbit. To go to the moon, it needs to fill its tanks back up while floating in space. To make this happen, SpaceX will first launch a dedicated Starship propellant depot into low Earth orbit. Think of it as a giant vacuum-insulated thermos bottle floating in space. Once the depot is parked in orbit, SpaceX will launch a rapid succession of Starship version 3 and version 4 tanker flights. These tankers will dock with the depot one by one, transferring their remaining liquid oxygen and methane into the storage tanks. SpaceX launches the uncrewed Starship human landing system into low Earth orbit. The HLS docks with the pre-filled propellant depot, absorbing hundreds of tons of subcooled methane and oxygen until its tanks are completely topped off. The fully fueled Starship HLS performs a massive translunar injection burn, breaking out of Earth's gravity and charting a course for a specialized near-rectilinear halo orbit around the Moon. NASA launches 4 astronauts aboard the Orion spacecraft atop the massive SLS rocket from Kennedy Space Center Pad 39B. Orion transits to the Moon and locks into the same lunar orbit. Orion tracks down the waiting Starship HLS in lunar orbit. The 2 spacecraft execute a manual docking maneuver. 2 astronauts open the hatches, leaving Orion and moving into the cavernous living quarters of the Starship HLS. Starship HLS detaches from Orion and utilizes its specialized mid-body landing thrusters to softly touch down at the lunar South Pole. The astronauts spend 6 full days conducting scientific experiments and collecting core samples before utilizing Starship's upper stage to blast back up into orbit, reuniting with their crewmates in Orion for the journey home. What we witnessed with Flight 12 wasn't just a test flight that ended in splashdown. It was a declaration of intent. By demonstrating real-time engine-out recovery, testing advanced hypersonic maneuvering profiles, and validating the structural integrity of the Block 3 design, SpaceX has proven that its rapid prototyping philosophy works. With NASA aligning its architecture to support the robust step-by-step build-up toward Artemis 4, the pieces of the puzzle are finally falling into place. We aren't just going back to the Moon to leave footprints. We're building an infrastructure that will open up the solar system for generations to come. The hardware is real, the pads are ready, and the countdown to the moon has officially begun. Stay tuned because the modern space age is moving faster than anyone thought possible.